Hello everyone, this is Priyanshu Choubey, Assistant Professor of India and University. Today we will going to talk about the soil electrical conductivity. What is the soil electrical conductivity and how to measure it? So let's see what is the soil electrical conductivity. Soil electrical conductivity. What is definition of a soil electrical conductivity? The electrical conductivity of the saturated extract electrical conductivity is an indirect expression of the total salt concentration in the soil without the reference to the nature and composition of the salts. A large range of units in use to describe salinity, uh, but DC seminence per meter, in short DS meter per square, instead of more centimeter per square in other literature in adopted as the standard measure of electrical conductivity and hence the salinity. It is customary to measure electrical conductivity at a standard temperature of 25 degree to take out of influence of temperature. So that is a must important to standard temperature here. So what is the objective of soil electrical conductivity? Let's see. And define electrical conductivity, cation exchange capacity, decimeter per meter, and EC method, EC 1:1 method, saline soil, sodic soil, anion, cation, nitrification, denitrification. So explain the role of electrical conductivity in soil health, list and describe inheritance factor that affect soil electrical conductivity. Describe the necessity and factor of salinity management, list and describe a problem related to electrical conductivity. Describe how electrical conductivity affects the soil function and measure soil electrical conductivity and interpret results. Next, let's see definitions. Already, I explained it. What is the soil electrical conductivity? But once time, let's see. Definition: anion. Anion, a negatively charged ion, and cation. Cation, a positively charged ion. So cation exchange capacity, in short form, CEC. Cation exchange capacity. So capacity of soil to exchange a cation soil with high clay or organic matter content have a higher cation exchange capacity than those soil low in clay and organic matter. And denitrification, conversion and loss of nitrate nitrogen to atmosphere in various gases forms due to lack of oxygen when soil becomes saturated with water. Dc per meter unit of a measurement for electrical conductivity of soil in dc Siemens per meter. Definition: EC method, standard expected laboratory method of soil electrical conductivity testing using a saturated paste extract. EC 1:1 method, soil EC testing method using a 1:1 soil water mixture that must be added for soil texture. Nitrification, conservation of ammonium compounds in organic material or fertilizer into nitrates and nitrates by soil bacteria, making a nitrogen available to plants. Nitrogen oxides, uh, family of nitrogen gases that can be generated by human activity and related to the atmosphere. Next one is a saline soil. What is a saline soil? So, saline soil with a higher content of soluble salts and negatively affect soil process, productivity, and overall soil health. Sodic soil, soil with a high content of salts and poor structure, water infiltration and drainage is prevented. Soil electrical conductivity, a measure of the amount of soil in salts in soil. Soil electrical conductivity affects the yield, crops, stable of plant nutrient availability, and soil microorganism activity such as the emissions of the greenhouse gases and respirations. Excess salts hinder plant by affecting the soil water balance. Third one is arid and semi-arid climates naturally have a higher salt content, and salinity is influenced by humans through cropping, irrigation, and the land management practices. Inherent factor affecting a soil electrical conductivity climate. So climate salts are more easily flushed through soil located in areas of high rainfall areas. Salt area flushed below the root zone into a groundwater or streams. Salts accumulate in a soil sound in dry areas. Inheritance factor affecting soil is the mineral content. Mineral content salt comes from the weathering of a mineral rocks found in soil. Factor for converting a very salinity unit to a deci cements per meter total soluble salt. So here is a unit conversion meter square per centimeter to a decimeter per meter into a one, like a more centimeter per unit to a deci per meter square into one, and meter second per meter square to a decimeter per inverse into a 0.01. So lots of factor for converting the salinity units. The EC value is the inversely proportional to the water content as an indirected in the conversions, like EC 1 ratio 1 is equal to 2 EC 1 ratio 2 is equal to 5 EC 1 ratio 5. So it should however be recalled that is a proportionality between a salt concentration and the soil moisture content only holds true for a higher soluble salts like sodium chlorides and sodium sulfate. For slightly soluble salts like lime, calcium carbonate, and to a lesser extent calcium sulfate, gypsum, like gypsum. Similar values of the concentration ratio apply since precipitation of this salt occurs upon a concentration. So exchangeable sodium percentage also here important here. The exchangeable sodium percentage corresponded to the amount of absorbed sodium compared to the EC, cation exchange capacity, and is expressed like cation exchange exchangeable sodium percentage is equal to exchange sodium percentage into 100 upon cation exchange capacity. So cation exchange capacity of the salt affected soil composed mainly of sodium, calcium, and magnesium as the dominated exchangeable cation can be expressed as cation exchange capacity is equal to exchange sodium and exchange calcium plus exchange magnesium here. So cation exchange capacity in the cation exchange capacity of the soil in the mo kg per dry soil and exchange sodium, exchange calcium, exchange magnesium, and corresponded to the amount of the absorbed sodium, calcium, and magnesium respectively. The exchange sodium percentage and the expression of the sodicity and the dispersion tendency of the soil. The soil solution has a major influence on the chemical properties of the soil absorption complex as uh, given by Gapon's equations like exchange sodium upon exchange calcium plus exchange magnesium is equal to kg in percentage sodium upon under root of K square and magnesium is plus magnesium is square upon 2. So where kg terms as Gapon constant in the exchange coefficient which has a value ranging between 0.010 to 0.0 uh, liter square to concentration of nitrogen, sodium and calcium and magnesium in the soil solution as the expressed in the milliliter. The Gapon equation demonstrates that a more concentrated soil solution results in a higher amount of exchange sodium percentage at the expense of exchange calcium and exchange magnesium casing and increases the exchangeable sodium percent. In the case of the dilution of the exchange calcium and the exchange magnesium will replace exchange sodium and ESP will decrease cation exchangeable sodium percentage. So the determination of the exchangeable sodium percentage can be made following an appropriate procedure in the laboratory. However, for a routine analysis of the large soil sample, this determination is too time consuming. Also, it requires expert handling the unless carefully determined. It might lead to a erroneous results, although the relationship between a pH and ESP is a complex when applied to a wide range of a soil, yet pH may be used as the satisfactory indication of the exchangeable sodium or a similar types of soil. So from and reclamation point of view, pH and exchangeable sodium percentage of the soil of the endogangetic plants are well correlated. Since pH can be easily and rapidly determined in the laboratory, this parameter has widely been used to assess the degree of the sodicity of the endogangetic plants in some areas. If the relationship between a pH and exchangeable sodium percentage, it is not satisfactory. The more tender determination of the cation exchange capacity and the exchangeable sodium may be required to elevated sodicity and related reclamation problems. So, relationship between pH and exchangeable sodium percentage of the soils of the endogangetic plants like 8 to 8.2 pH here. So exchangeable sodium percentage 28.2 to 8.4 to exchangeable sodium percentage 20 to 35. So pHs and pH2 are a pH of the saturated soil paste and 1:2 soil water suspension respectively. So Sodium absorption ratio, because of the equilibrium existing between the soil and soil solution, it is possible to measure the sodicity from sodium absorption ratio derived from the concentration of sodium, calcium, and magnesium in the soil solution. So, sodium absorption ratio is equal to sodium upon under root calcium square plus magnesium square upon 2. So where sodium absorption ratio is the sodium absorption ratio of the saturation extract of the soil. The sodium absorption ratio can be determined in the laboratory more easily than electrical exchangeable sodium percentage, and help estimate the exchange sodium percentage from a combination of equation like first and second, which is already I told you. So, ESP is equal kg and sodium absorption ratio upon a 1 plus a kg sodium absorption ratio into 100. So, for a wide range of sulfur following like a relation here. Exchangeable sodium percentage is equal to 100 upon sodium absorption ratio into upon 1 plus sodium percentage ratio here. So managing a soil easy cropping so cropping leave a crop residues to add organic matter and to limited evaporation, low organic matter plus poor infiltration and the poor drainage and saturated soil compaction is equal to increase electrical conductivity and a decrease in the soil ability to buffer. So managing irrigation, the salinity of water affected the salinity of soil. Extra water can help flush salts from the soil. Managing our soil electrical conductivity, land use ensuring that the least amount of the compaction and the erosion occur improves soil electrical conductivity. Managing soil application, fertilizers, manure, compost, application of fertilizer, manure, compost, monitoring to municipal waste is necessary. Nitrogen increase salinity, soil function and EC. As the EC electrical conductivity increases, the soil microorganism activity decreases, affecting respiration residues, decomposition, nitrification, and denitrification. Sodic soil have a poor soil structure and the poor infiltration and drainage, as well as the increased toxicity. So, electrical conductivity indirectly indicates the amount of water and water soluble nutrient available for the plant uptake. So, reclamation and management of soil affected soils also we talked about it, but some more points here. The primary object of reclamation and management of salt affected soil is to residues of soluble salt and exchangeable sodium to leaves and that permit ideal or near ideal plant growth so that the productivity of this soil is restored. For that replacement of excess sodium ions from the exchange complex and leaching out the salt below that root zone to do accomplish that provision of the adequate drainage C index. C index. It is a request to achieve this objective without adequate overnight. It takes accumulated enough to reduce crop growth. However, water infiltration reclamation can take just as long for systematic planning for carrying out a reclamation program, proper characterization and uh, causes of the problem required that extent on kinds of the salinity and sodicity problem have to be truly understood. Understanding the implications and cost of reclamation plants is important. For reclamation for the salt affected soil, physically, chemically, and biological methods have been developed. Uh, uh, these are we discussed. Drainage. Drainage, there must be drainage to reclaim the sodic saline or a saline sodic soil. Make sure your have a adequate drainage. What is a drainage now here? So how do I make sure I have it? What can I do to improve it? So drainage is the unimplement downward movement of the water beyond of the crop root zone. It is ability to move water through the out of the root zone. Hard paints break the bedrocks and shallow water tables impede drainage. Sign of poor drainage includes surface ponding, flow in nitrification, or soil that remains wet for the longest period of the time. Digging within the below the root zone can also indicate where a drainage problem exists. In most of the cases of poor drainage can be improved by the breaking up and hard pin with a deep tillage. If drainage is impeded by the shallow water table and bedrock, artificial drainage must be installed or another use for the land might need to be considered. Physical reclamation, the type of the reclamation involves the physical and mechanical mean to improve the salts and or to improve permeability and thereby the internal drainage within the soil profile. This method includes deep plowing, soiling profile, inversion, sanding, flushing, and scrubbing. Deploying and subsoiling method, the mechanically break and the impermeable layers and cemented subsoil layer are hard pan is the soil profile at some depth to enhance the infiltration and the transportation of salts dissolved in water to deeper soil layers. Deep Deep plowing has been shown to benefit water penetration, aeration, uh, plant growth in the poorly structured soil. However, the benefit of the deep plowing are short-lived, especially sodic soil. Profile inverse can be employed is in such situation where a surface soil is relatively free of salt and sodium, but soil below in a sodic saline and um, saline sodic. In this method, good surface soil is retained while the salty subsoil is inverted down the profile. It is, however, the cumbersome procedure. Hence, it is not followed by the farmer. Sometimes sand is a mix when the salt affected soil is improved the permeability and air water relation uh, in the root zone. However, in the clay sodic soil, inadequate the quantities of the sand silt rather create problem due to a sand cementing effect. In such cases, a large quantities of the sand have to be applied to check the cementing effect that that at a times seems impractical for a large area. Flushing involves washing away the surface accumulated salts by the flushing water over the surface. It is sometimes used to desaline the soil having a surface salt crust because the amount of salt that can be flushed from the soil is rather small. This method does not have much practical significance. Scrubbing the salt that have accumulated on the soil surface by mechanical means has had only limited success, although many farmers have restored to the procedure. It might temporarily improve a crop growth, but the unlimited disposal of a salt still poses a major problem. Also, this method fails to give a permanent solution under shallow water table condition where salt can again rise and accumulated at the surface due to due to evapotranspiration. Chemical reclamation. Chemical reclamation of the sodic soil requires the removal of the parts or most of the exchangeable sodium, removal of the sodium physical structure, and the lowering of the soil pH. The exchangeable sodium replaced by the more favorable calcium ions according to the exchangeable reaction given in uh, uh, by equation like 2 sodium minus x plus calcium is equal to calcium x plus 2 sodium. So where x is the exchangeable complex, calcium needed for this relation can be furnished by the either calcium based am- amendment or calcium carbonate present in the soil, whose solubility may be enhanced by the application of organic
Is a particular importance in the absorption of the water and the circulation of air. A desirable structure should have a higher proportion of medium size aggregates and an prescribable number of an appreciable number of the large pores through which water and air can move. Structure of both the B horizon and A horizon is a very crucial to a proper drainage in infiltration and productivity in soil with a poor structure root penetration in limited, thus the reducing the plant's access to water and nutrients. The structure of the A horizon has received a great deal of attention because of the its relation to seedbed preparation, B horizon potential aeration, water infiltration, overall soil health. So let's see soil structure. The primary soil particles do not exit as um, such in a natural condition, but the bonded together into a large units of aggregates, usually termed as secondary particles. These aggregates formed under a natural condition are called pads. Whereas an irregular shaped coherent mass of soil formed during a tillage operation is called a clod. Solid structure is defined as the arrangement of a primary and secondary soil particle in a certain structure pattern. This arrangement result in information of different sized soil pores. Therefore, a soil structure may also be defined as the arrangement of the various sized soil pores in certain structure pattern. So now is the important of soil structure. Soil structure influence almost all the plant growth factors uh, like water supply, retention, aeration, availability of a plant, nutrient, heat, root penetration, microbial activity, and etc. Strong aggregations decreases uh, decrease detachability and transportability of soil particles via water and wind and thus reduce the runoff and soil erosion. Solid structure is useful for a classification of soils. It is affected by a tillage, cultivation, and application of fertilizer, manure, lime, gypsum, and irrigation. Classifications of soil structure. Uh, Soil structure is described and classified based on the types of the type as determined by a shape and arrangement. The class as a differentiated by a size, and third one is the grade as a determined by a distinctness and the durability of pads. So types of structure based on shape and arrangement of a pad. Solid structure is classified as a simple and the compounds, and simple structure, natural cleavage, planes are absent. Simple structure is of two types: uh, simple granite and massive. In single granite structure, particles are completely unattached to each other, as in case of a loose sand. And while in a massive structure, particles are the bonded in a large cohesion, non-structured mass. In case of a surface crust, plow, pane, and the clay pan. In compound structure, In compound structure, natural cleavage planes are visible with a naked eyes. This shape are individual paired and described according to relative length and vertical and horizontal axis by a shape and their edges. Compound structure is four types of depending upon a shape and their characteristics like first one, types of compound soil structure and their characteristics. Type one is a blocky all the shape and characteristics of a blocky, all the three dimensional of a pets are of about same size, providing a shape of a block having a flat and rounded face. These pets are further divided into a angular blocky and the subangular blocky. In the former face are a flat and the edges and corner are sharp, while in the letterfish and the edges are mainly rounded. The blocky structure usually found in a B horizon and promotes good drainage, aeration, and root penetration. Second one is a prismatic. The pads are analogate more in vertical than in a horizontal direction. Given a column-like shape, vertical cleavage planes are the predominant. When the top of pads are relatively angular and flat, is called a prismatic. And when rounded, it is called a columnar. Prismatic structure commonly occurs in subsurface horizon in a arid and semi-arid region, and poorly drained soil of a humid region having a swelling type of clay. Platy horizontal axis is a longer than a vertical axis, resulting the plate-like appearance. Horizontal cleavage planes are predominant. When the pad are thick, they are called platy, and when thin are called laminar. Platy structure is often inherited from a parent material and may also be formed due to a compaction of a clay soil by a heavy machinery. Plate structure restricted infiltration and percolation and aeration soil. Spherical pits are roughly spherical and granular and subdivided into a granular and the crumbs. Granular structure is less porous than the thumb due to a low organic matter content. Spherical structure formed by a biotic activity in surface horizon and promotes infiltration, percolation, aeration, and root penetration in soil. Classes of soil structure on the basis of size aggregates. Each type of soil structure is further subdivided into five classes. The size of aggregates is certainer of quantitative classifications of soil structure. Coarse and sand size aggregates are more favorable for plant growth, and very smaller or very large aggregates. So grade of soil structure. Grades of soil structure, it is a qualitative means of the classification of soil structure. Qualitative means of classification of soil structure. Grades of soil structure are the identified on the basis of the stability of the grades. Stability of a grades refers to their resistance to dis- disruption by impact of raindrops under a submerged condition. It is influenced by a moisture content amount and type of clay and nature of the adsorbed cation and organic matter content of a soil. High moisture content, colonite clay, developed cations, and high organic matter content make the aggregates relatively soft. Three structure grades have been identified as a weak, moderate, and strong. So, grades of soil structure. To describe to soil structure, the sequence, grade, class, and type of the followed for example: strong, porous, angular, blocky, moderate, thin, platy, and weak, fine, prismatic structure. Like a great weak, first one is weak, so characteristics are poorly formed, indistinct pads with which are not as stable. Moderately developed pads which are fairly stable and distinct. A strong, a very well developed pad which are quite stable and distinct. So genesis of structure refers to the uh, cases and method of formation of aggregates. The following two processes are the involved in the genesis of structure. First one is a flocculation. Flocculation. Flocculation, it is an electrokinetic phenomena, is in which positive and negative charge are involved in a soil water suspension, and the clay particles with a high zeta potential repel each other. With the addition of flocculating agent, zeta potential is lowered. The particles come closer and attract each other, resulting in the formation of floccles of silt size. Floccles are stable as long as the flocculating agent is present. Flocculations also take place due to hydration, high soluble salt concentration, and the presence of the divalent or trivalent cations. Cementation of floccles. It refers to consolidation of a clay foccolates by a cementing material so that they may not get displaced once these have been flocculate, as flocculates are not large than a silt size. Therefore, flocculations would be unfavorable for a plant unless these are further aggregates by inorganic calcium carbonate oxides of iron and aluminium and organic matter cementing materials. Flocculation of a clay particles is therefore the request for aggregation. So aggregation is always refers to a flocculation plus where a plus in the cementing agent. Factors influence the formation and the stability of the soil structure. So first one is the physical factors. Physical factors includes the wetting and drying and freezing and thawing. Alternate wetting and drying leads to a formation of a smaller aggregates, particularly in the fine texture soil. Drying causes a shrinkage of the soil mass, and when the large dry cloud is wetted, rapid entry of water causes unequal swelling in the cloud, and the cloud is fragmented along the cleavage plane. In the process of wetting, increasing the pressure of the interrupt air cases distribution of the large cloud into a smaller pieces. Similarly, freezing cases cracks in the large plot by expressions of water. These cracks, cracks takes in more water upon thawing and get enlarged further of the refreezing. Chemical factor. The chemical factors includes the exchangeable cation and the binding materials. Clay acts as a cementing agents, also swells shrinkage upon the wetting and drying. In certain also small aggregates are held together by a covering of the clay particles. Exchangeable ions such as the calcium, magnesium and potassium have a fluctuations effect on the clay, while sodium has a dispersing effect. The sodium ions dominating on exchangeable complex of a sodic soil cause particles or repel each other and hinder the formation of the aggregates. The divalent cations such as the calcium and magnesium causes the individual colloidal particles to come together and form foccolates. Calcium also help in binding the organic colloids and clay particles. Hydrate Swaxe oxide from almost completely inversible collide upon dehydration and uh, and help in forming stable aggregates as in the lateric soil, oxysol and alti soil called the lateric soil of the humid tropics. So Swaxe oxides also formed a complex with humus and calcium carbonate precipitating around soil particles act as the cementing materials for aggregates and imparts a stability to soil aggregates, a soluble salt, and to enhance flocculation of the clay even in the sodium saturated clays. Organic compounds play a key role in aggregation and stabilization of soil structure. Fat, wax, lignin, protein, raising, etc. also help stabilizing the soil aggregates. Humans help in the aggregation by the forming clay humus complex. Only a calcium humus is a flocculate Floculating due its tendency of a form a complex with organic compounds through the the coordinations linkage the magnesium potassium and hydrogen and sodium humans is defocculated and does not help in aggregation synthetic soil conditions. Long carbon chain organic compounds are also used for soil aggregation. These compounds attach time wells to the inner exchange sites of the clay and the bind the clay particles together. At addition of these compounds in relatively small amounts and can the produce a good structure even a sandy soil. Biological effects, biological factors. Biological factors, the plants and plant residues help the soil particles to bind together. Um Gelinations, organic compounds extruded from a root binds and soil particles together. Root hairs penetrate soil clots to create a point of the weakness and ultimately break the clot into aggregates. This also helps the soil particles stick together in a granular form. Plant residues serve as a food for microbes, which play a prime role in the aggregates formation and the produce sticky substance or decompositions. Microorganisms decompose plant and animal residues form humus, and this humus binds the particles